awesome stuff. Let's talk to one of the researchers very familiar with the development of this, Surabhi Sachdev, a researcher at Caltech's LIGO laboratory, joining us this evening. Surabhi, thanks for being with us. How truly astonishing is this recording, and what does this mean?
This is very, very exciting, and we were all very surprised that it came so early in the observing run. This opens an entirely new window to how we can see universe. We can see objects that we could never have seen before with electromagnetic waves, for instance, merger of binary black holes, and we expect to see many, many more exotic objects that we would not be able to see otherwise. So it opens up a very exciting field.
Now, Surabhi, I was reading about the instruments that you guys use to measure this sound within the atmosphere. Tell me how, and they're little lasers, right? Tell me how these lasers work when they encounter this gravitational pulse.
So gravitational waves are ripples in space-time, and what they do is they stretch and squeeze space-time. And our interferometer is an L-shaped interferometer with arms 4 kilometers in length. And what happens is when the gravitational waves hit these arms, they're supposed to change the distance between the mirrors at the end of these arms. Now, to measure the change in the distance, you cannot use like a measuring stick, because measuring stick would also increase or decrease in length with the gravitational waves. So what we do is we send a laser beam, and we try to measure the change in time that it takes for the laser to travel that distance, because the speed of the laser, which is the speed of light, is constant. And so
Surabhi, what does this mean for astrophysics in general? Is there something we can glean out of this?
So we can, for instance, infer how many such objects exist in the universe, like, a binary black hole system. So we can set a rate of these mergers in the local universe.
It is crazy, awesome stuff. Surabhi, thank you so much for being with us. We're all pretty excited here at the Weather Channel. Einstein, a genius, and now we know he was right.
Right. Wow. So basically, you've measured the sound of these two black holes coming together as one, and now they said one of these black holes was about 26 times the size of the sun. Another, I've got it written down. It's like, one was 36 times the size of the sun and 29 times the size of the sun, and they came together, and you actually heard a sound in the note of C. That was them coming together.
Awesome stuff. We'll be right back.